Okay, look at this thing. This massive vessel is the heart of the whole operation. It's called a reactor, and it's basically the core of what's known as a distillate hydrotreater. Inside this beast, under some seriously intense pressure and heat, raw, kind of dirty fuel gets chemically scrubbed clean of nasty stuff like sulfur and nitrogen.
But, this reactor can't do it all by itself, not even close. It's just one part of a huge, complex system of pumps and heaters and separators. So the real question is, how does this whole symphony of steel actually work together to get the job done? Let's follow the flow, step by step, and find out.
So here's the plan for our tour through this place, Unit 33. We'll kick things off with the initial prep work. Then we'll crank up the heat, watch the reaction happen, separate all the different components, and finally, polish the final product. Ready? Let's dive in. First up, fuel's first cleaning. You can kind of think of this as a prep school for our fuel molecules, right? Before they can handle the crazy conditions inside the reactor, they've got to be cleaned up and ready for what's coming. So the whole thing starts at the coalescer, which is basically just a giant water separator. From there, the fuel flows through these cartridge filters to pull out any solid junk. And this is super important, because if you run without these filters, you can wreck the expensive catalyst we'll see later on. Next up is the feed surge drum, which is like a big holding tank that makes sure the flow is nice and steady. Finally, the massive charge pumps get to work, cranking up the pressure to get the fuel ready for the main event. All right, section 2, heating to react. Our feed is clean, it's pressurized, so now it is time to turn up the heat. And I mean way up. This is the trial by fire before it gets anywhere near the reactor. Okay, this is where things get really smart. The liquid fuel gets mixed with hydrogen, and then it goes into a whole series of heat exchangers. The system is designed to be incredibly efficient. The super hot stuff coming out of the reactor is used to heat up the cool stuff going in. It's this brilliant energy-saving loop. And this preheating is absolutely critical, because that reactor needs a very, very specific temperature to do its job. Only after it's soaked up all that recycled heat does the mixture go to the main charge heater for that final blast of heat to kickstart the reaction. And that brings us right here to section 3, the reactor's core. This is it. This is the main event we've been building up to. This is where the real purification, the chemical magic, actually goes down. Every single pump, every filter, every heater in this entire unit has just one job: to get the fuel perfectly prepared for what's about to happen inside this one single vessel. The hot, pressurized mix of fuel and hydrogen comes in at the top of the reactor and flows straight down, passing through 2 different sections, or beds. And these beds are packed with a very special substance that makes this whole process even possible. And that substance is a catalyst. So what is that? Well, in simple terms, a catalyst is kind of like a chemical matchmaker. It creates the absolute perfect environment for a reaction to happen really fast and efficiently, but it doesn't get used up itself. In this reactor, the catalyst's whole job is to grab onto those sulfur and nitrogen molecules and, with a little help from the hydrogen, turn them into harmless stuff. And that's the whole point, right? Because sulfur and nitrogen cause all sorts of nasty emissions, so getting them out means a much, much cleaner fuel. And this is not some set it and forget it kind of deal. This quote is from the actual operating manual, and it shows you just how delicate this all is. A human operator has to watch the temperatures inside constantly. If it's too hot or too cold, the reaction just doesn't work right. It could even damage the catalyst, damage the product. It's a non-stop, high-stakes balancing act. All right, so the reaction's done, but now we've got a new challenge. What's coming out of the reactor is this hot, messy mixture of purified liquid diesel, a bunch of leftover hydrogen, and some new waste gases. So for our 4th section, the Great Separation, we gotta figure out how to sort all this out. So the separation happens in 2 main stages. First, everything goes into the separator. It's a big tank that just lets the gas, the liquid fuel, and some contaminated water naturally settle into 3 different layers. Think of it as the rough cut. The liquid fuel then moves on to the stripper for the final purifying step, which we'll get to in just a minute. But hang on, what about all that leftover hydrogen gas from the separator? It would be crazy wasteful to just get rid of it. So instead, the plant captures it, cleans it all up, and sends it right back to the beginning of the line. This is the recycle gas journey. So the gas, which is now full of hydrogen sulfide, goes into a scrubber tower. In there, a chemical called amine, which is like a special liquid sponge, washes out all that nasty H2S. Then it goes through a knockout drum to get rid of any stray liquid droplets before these huge recycle gas compressors repressurize it. Finally, it gets mixed with a little bit of fresh makeup hydrogen and it's sent right back to the start to treat more fuel. It's a closed loop. So, while the gas is off on its little recycling adventure, let's get back to our liquid fuel. It's time for Section 5, stripping to purity. This is the last big purification step to make sure the diesel meets all the super strict quality specs. That liquid fuel from the separator gets fed into this tall tower called the stripper. Now inside this tower are 30 separate trays. As the liquid trickles down from tray to tray, hot steam is shot in from the bottom. This steam bubbles up and it literally strips away any leftover light stuff and dissolved sour gas. That vapor goes out the top, leaving just the pure, stable diesel product at the bottom. We are in the home stretch now. Section 6, the final product. Our diesel is pure, but it's still unbelievably hot. Before it can go to storage, it needs one last cool down and polish. The journey for our molecule ends with 2 last stops. First, the hot diesel runs through a bunch of air fin coolers. They're basically just giant radiators with huge fans that bring the temperature down safely. Then, it flows through one last coalescer just to squeeze out any tiny last drops of water. And from there, the clean, dry, on-spec diesel is finally finished and sent to a storage tank. And that's the whole trip. From a raw fuel contaminated with water, gunk, and sulfur, we've followed it through this incredible, meticulously engineered system to create the clean, reliable fuel that is so essential to our modern world. Kind of makes you think, doesn't it? The next time you see a truck rumbling down the highway or a freight train rolling by, you can picture this amazing, invisible process just humming along in the background. What other incredibly complex systems like this are hidden inside the products we use every single day?